Hi all, in this video we are going to talk about a little bit more about the text processing. So anyway, we have in this session we have actually seen about the text processing, right? So just to make our hands dirty, we'll just try a little bit of text processing here. So the first thing is, say if you have not installed NLTK package from the Google Colab. So I'm using the Google Colab, okay? So then the first thing which you have to do is that you have to install the NLTK package. That's the first thing which you have to do. Then I'm just downloading all the packages, so you could actually give it like nltk.download all, and the all has to be within the codes, otherwise it will not work, because if you simply search in the internet, it will show you the how to use this download all but without the codes. But if you are using it in the Google Colab, then you have to definitely have this codes here, okay? So just make sure that you are having it. So it will download and it will unzip and everything. So now everything is basically here in our Google Colab itself, okay? So that's what you have to understand. And next one is nothing but we are actually going to try the different text pre-processing. So for that we need an NLTK package. So this we have already imported, and it's all there, we know that. And then comes the string package. The string package, it's for working with all the slides, the string operations, the digit symbols, and etc. And we also have this RE. RE is basically the regular expression. So regular expression in NLTK package is also called as regex. Regex is regular expressions, regular and expressions, and that is basically used like we can give a particular pattern, and then it will locate those particular pattern within a specific string, right, or a sentence or a document or whatever it is. So whatever be our input, accordingly it will actually find out, and it will just give us back that kind of output. So if we want to work with strings, we have to use the string. And if you want to work with certain patterns or looking for certain patterns in your document, then you can also work with regex. So in fact, for regex we do have a lot of functionalities which are there, and there are a lot of it's kind of one particular session itself to work on and understand. But as we don't have that much of time to understand about it, you can explore by yourself. But otherwise you can use this regular expressions. RE is for regular expressions. It is for finding certain patterns within a document or a sentence or whatever be your character input, right? So that's what we use for RE, okay? And say the first thing which we are going to do is like, we are going to remove the text lowercase. Say if we have an uppercase in our in the input, we are going to reduce it to a lowercase. So that's what we are actually doing. So the first one is basically we are using a Python function, so text lowercase, and it is actually taking this text as the input, and it is just converting it into a text.lower. So as simple as that. So this is our text which is actually given over here, and this text is actually so text underscore lowercase. This is the function, right? This is the same function which we are basically using, and we are giving this input str as the parameter to this particular function. So when we do that, you could actually notice that all the upper cases, so these are all the upper cases. So I have given enough of command lines, because later if you want to go back and see into this later, then it should not be, you should not be in a situation that you don't know what is actually happening. So later after after 1 year also, if you open this, if you want to go through this and refresh it, you should be able to understand what is happening. So you will have proper command lines here, so it will not be an issue for you later as well. So H is basically converted into a lowercase, right? So whatever say NLP is actually uppercase, that is actually converted into a lowercase. So this is one of your text cleaning methods itself, okay? So this is part of your text pre-processing, and this is nothing but what you are basically doing is actually one of the text pre-processing method, that is nothing but converting an uppercase letter into a lowercase one, okay? And then the next one is basically removing the numbers. So in removing the numbers, say if you have certain numbers in your text, that is just removed, that's all. So there are only 5 weeks for NLP course, so that 5 is actually removed, and there is a gap there, okay? So it doesn't matter, and here you are actually removing 12 weeks. So that is just removed, but you will have that space there itself, right? So here the function which we are using is remove numbers, and we are actually taking a text as the parameter for this. And when you look at here, you are actually using a regular expression. So it's a regular expression. So in the regular from within the regular expression pattern, you are actually calling a function called sub. Okay, so where you are actually giving this I mean, like, wherever you see a particular number, what you have to do, you have to replace it with a space. That is what actually you are doing. And where you have to do that, you have to do that from within the text which is actually given, right? And you have to finally return the result, right? So this is your input str, right? So you are given with a text. So this text will be actually passed over here. This is exactly the same text which is actually passed as a parameter here as well. And you are simply calling remove numbers of str. So this particular text is basically passed over here, and it is calling this particular re.sub function, and wherever it see a particular number, that is actually replaced with a that is removed, and it is actually replaced with this space. So that is what actually we are getting our answer as such, right? So this is also one of your pre-processing methods. Okay. So now comes the next one. Next one is basically called as the inflict module. So inflict module is basically, say inflection is basically, you will learn it in the morphological analysis. So in morphological analysis, you have different type of inflection which you learn there. So basically it is like you can actually generate the plural, singular nouns and ordinals and all those stuff. It can even convert the numbers into words. So I don't want to leave as, say if I have something like one second, it's getting stuck. If I have some numbers like 5, instead of leaving it as blank, I would rather be happy if you could convert it into a word itself, right? So for that I can use this inflict library. So in this inflict library, you are actually engaging the inflict.engine, and you are actually converting the number. So convert number of text. So wherever you get a text, you have to convert that into a number. So for that, basically you are splitting your text, and initially you have this new string. So for each word in the string, you are actually searching for whether there is a digit. If there is a digit, then you have to convert that into a particular word, and then you are actually putting them into an array temp. Okay, so you are just appending it into the new string, that's all. And if the word is as it is, then you can actually just simply append it. So you don't have to convert it, you can simply append it. Say if it is like 5, then you can keep it as 5 itself. Okay, but if it is a number 5, then you have to convert it into the textual 5 and then append it. So that's what they are actually doing it here in this particular loop. So you don't have to worry about all this, because you have these functions all around there. You can simply call them. You should know that this is the function which you have to use, and this is how it works. That's the only thing which you need to know. And basically you will be using, and you will be joining it by using the spaces. And say if there are 5 weeks, so instead what we will do is that you will convert it into 5, and then you are actually using it in your inputs. And so you are simply calling this convert number of input string. So wherever you get this 5, it will be actually taken a number, so you have to convert. So this will happen here. But if you have something like, say I will just add say I thought there are 12 weeks, there are 12 weeks, and say just imagine that I am just adding 12 weeks and 3 days. Okay, so now I hope it will work. I hope it will not yeah. So when you look at it, see here, it's like 12 weeks and the 3 days is just kept as such. Okay, so this is what I wanted to tell you, right? And then the next one is removing the punctuation. So punctuation could be any punctuation here, right? So for the removing the punctuation, you are actually using you are again taking the text as such, right? And then you are actually translating it. So while you are translating it, str.make translation. So wherever you have to see that you are actually changing or replacing it with the spaces. Okay, so that's what I mean, like you don't want those in your answer, so you're just leaving it with the spaces. That's what. So you will look for these punctuations and you are actually converting them into strings. So that's what actually you are actually translating them into into spaces. So that's what you are doing. So this is the this is a text which is actually given here. So when you look at it, there are lot of punctuation. So this is actually a punctuation, this is actually a punctuation, and this is a punctuation. There are so many things which are actually coming in the picture. When you look at it, there is nothing other than space. So all those things are basically converted into space. Here if you look at here, there is a bigger space because you have two things which is actually converted, right? So that's why you have a bigger space there. So it's just like that. And then the next one is basically about the removing the white spaces itself. So after that you can basically do that. So always understand that removing white spaces basically works with the help of the split and join function. So there is something like which will act hand in hand. So when you call it, so it's like remove white space of the text. So this is the text which is actually given to you. So wherever there is white spaces, so it's not the normal spaces between the words which acts as the separator which is removed. It is actually the unwanted spaces which is so if you have a normal space between a word, it will act as a separator. That will not be, that white space will not be removed. Okay, so if there are white spaces, more than one white space, then that only will be removed. So each of your word is basically split and it will look for the white spaces, and if you have white spaces, it will remove it and it will actually join. So it will take this we don't and then it will remove all these white spaces. Then if it see this particular need, it will actually join it with. So you are splitting your complete string and then joining it. So that is what is basically happening in. So here it breaks up the string as a list, and then again it is actually joining it back, okay, and joining it back with a single space between each word. That is what is actually happening here. So this for removing the white spaces, as white spaces actually will act as a separator, it is you have to be really careful. And so this is how this combination of this join and the split will help you to remove the white spaces from within the text with textual content. Okay, so then comes about the removing the default stop words. So for that, first you need to know that who all are the stop words, right? So we are just taking about the English language. So about the English language, if you could see, there are so many stop words like this. So how can you remove it? So for that, we do have a package itself. So we can actually download it from the NLTK. So nltk.download of stop words. That means that all the stop words will be now, I mean, like it's a lexicon. Lexicon means it's a dictionary. So this is a dictionary, or it's a repository of the stop words. Okay, so you are actually importing it. So you are actually importing it from the NLTK corpus and import stop words. So you are importing it, and then you have to tokenize it, right? And you are actually using word tokenize. So how are you actually doing it? So you do have a function remove stop word. So you don't have to even worry about how this actually remove stop word works. You do have a function remove stop word. That's what you should know. So if there is a text which is there, you can actually simply call this remove stop word and of the example text, because this is the example text or the document or whatever it is, right? Now just for our understand that there is something called stop word. So what you will do is that you are actually setting it as English alone. So this function will work only for the English stop words, and then you are actually tokenizing it. That means like this is a sample, like that you are actually going to split it into different tokens, right? Then you are going to filter it. How are you filter it? Word for each word in the word tokens, if word not in the stop words. So if the word is not in the stop words, you are just going to like filter it, right? So you are going to filter, and so you are removing all the stop words, right? And if the word is not in the stop word list, then what you are doing, you are actually putting it in the filtered text. So all the words which are not in the stop words will be in this filtered list, and then finally what are you doing, you are actually returning this filtered text. So that is what this list of words which are not as part of the stop words will be displayed back to you, right? So this is how this particular remove stop word works. But when you actually work with a real scenario, you don't have to worry about how this stop word works, but still it is good. It is always good to understand how it works, but otherwise you should know that there is a function called remove_stop words which will help you, and you can actually pass the text or the document text or whatever it is inside here, which will help you to remove all the stop words. So this is also one of your text cleaning method or pre-processing method. Now comes stemming. So stemming is very, very important. So stemming is basically like if you have a word, okay, you need to find out the root of that particular word, root form of that particular word, right? So that is what it is. Say cats, you need to find that cat is the root word. Foxes, then you need to find out the root word is fox, right? Walked, then you need to find out the root word is walk, right? So that is what is basically stemming is all about. Say there are certain examples which are given here. Say connect, its root word is connect, connected, it is connect, connection, it is connect, connections, it is connect. So like that you need to find out the root word. But when you are actually doing like this, there are certain issues which comes in the picture, like say if you have friend, friend, friends, friend, friended, friend, but friendly, it is actually giving it as friendly, so which is actually not correct, right? So there could be some so that's why we do have different type of stemmers which are available. We have Porter stemmer, snowball stemmer, Lancaster stemmer. There are different type of stemmer. In that, the most commonly used one is basically Porter stemmer. So these are different kind of stemmers which will help you to stem your word. Stem your word means it will take each word as a token. I mean, like each word as an input, and it will give you the root of that particular. It will predict the root of that particular word, right, based on a dictionary. So this is how the stemmers work. So when you look at it, so normally when you are actually using a stemmer, you have to simply call this particular function stem words of text, that's all. So this will be your original text that you want to stem, and say for each of the word in this particular sentence, or say a document text, what you have to do, you need to find out the root word, right? So that's what you wanted to do. So for that, what you want to know is that you need to know this is stem underscore word is the words is nothing but the stemmer, right? So this is what we will also see different stemmers later, but as of now just understand, as this is part of your text pre-processing, understand how this works. So you are basically having this stem words, and then you are actually passing the text, right? Then word tokens. So word tokens, you are actually tokenizing all the words. So that's why you use this particular function word underscore tokenize upon the text. So that means that natural language processing, like that, it is tokenized. Then you are actually calling the stemmer. So here it is basically you calling the simple stemmer function. So instead of this stemmer, you can use Porter stemmer, you can use Lancaster stemmer, snowball stemmer. So this is where you will actually change it, right? So stemmer dot stem of word for word in tokens. So that means that you are actually changing it into, and you will return the stems, right? So when you look at the output, you could see that you are getting a lot of all the what is that, the root word of it. So when you look at the interdisciplinary, its root word is basically wrong. When you look at the computer, it is actually it is actually given as compute, which is actually wrong, right? Science, it is actually science. So there are a lot of issues according to the stemmer, which will, so some stemmers nowadays have actually advanced a lot, and it will give you better outputs, right? So in this example, if you could see that it is actually whatever we have imported is Porter stemmer, and our stemmer is basically the Porter stemmer, right? So when we use a Porter stemmer, it's actually giving you this exercise. So it's just to give you a small I mean, like a little bit smaller example. We have actually used the same thing, but say we want to find out the root for each of these terms, that it's actually giving program, right? So this is also the Porter stemmer example, and the same way we are actually trying a little bit more simple example where programmers program with. So it is also giving you this thing, but it's not giving you the proper output, but still it's giving you the one which you have, right? So this is one example for you. Now in this example, what we are going to see is that we have already seen the Porter stemmer, and we have this with the languages, programmers, programming, and also languages. But when you look at the language, it is actually giving it as language. So it's not that if you use something, it is perfectly correct. No, it depends upon how it is actually programmed, because this Porter stemmer itself is a program, right? So now when we try the same thing with a snowball, you might get it like the languages, if you could say, it's all the language only. So cared, it is care, university, it is universe, so which is wrong, and fairly, it is fair, that is right, easily, it is wrong, and singing, it is sing, that's correct, sing, sung, even sung, it is sung, actually given, it's wrong, singer is actually singer, and sportingly, it is actually sport, and programming, it is actually program. So this is fine. But when you look at the programming here, it is program, yes, it's okay. So I mean, like there are certain similarities, but at the same time there are certain dissimilarities also, right? And so this is how actually you will actually incorporate two different stemmers. So you have to import whichever specific stemmer which you want to use for your program and for your application. You have to incorporate that and from NLTK package and use it. Okay. Then comes the lemmatization. So when it comes to the lemmatization, so understand that lemmatization considers the context. Okay. So it will definitely consider the context where a particular it is called as a lemma. Okay. So I mean, like if in NLTK package, so if you use this lemmatization, it will actually convert it into its root form, but it will mainly consider the context of that particular item. So when you look at here, actually you are actually importing the word net lemmatizer, okay, and you are also importing this word tokenizer because you want to tokenize the whole words, right? And your lemmatizer is basically the word net lemmatizer. Okay, so how can you actually lemmatize a word, and you are actually giving it as text. So this is the text which is actually passed here. You are first tokenizing it, so that means you are actually dividing it into various words, and then lemmatizer dot lemmatize of word pos equal to v. I mean, like you are actually looking for the verb, okay, for each word in word tokens, right? So included. So that means that you are trying to incorporate the understanding about the whole word itself. Okay, so lemmatized word means what will happen is that natural language, it will just give you almost all the individual words, right? So that's what you are actually doing. So you are doing so that's all for this session, and if you have any doubts, please always get back to me. Thank you so much.